The worldview problem in data analysis. The worldview problem in data analysis is a very major problem in data analysis. It isn't new. It's been a major problem since the earliest days of data analysis, such as, for example, Kepler and Galileo's analyses leading to the heliocentric theory of the solar system. It is a very widespread problem today due to the heavy use of data analysis, data science, statistics has become universal in the modern world, especially with computers and the collection of large amounts of data. What is a worldview? A worldview is a commitment, a fundamental orientation of the heart that can be expressed as a story or in a set of presuppositions, assumptions that may be true, partially true, or completely false, which we hold consciously or subconsciously about the basic constitution of reality, and that provides that foundation on which we live and move and have our being. The problem with the worldview is that the vast majority of people will reject or frequently not even see or process data or logical analysis perceived to contradict their worldview. This is true regardless of intelligence, education level, political affiliation, or knowledge of cognitive biases such as the worldview problem. This is a problem in science, technology, politics. It's easy to see in other people. When we see someone that has a different worldview from us, perhaps you're a Democrat and you wonder how Republicans could swallow a common Republican talking point so easily. And if you're a Republican, you're probably astounded at Democrats doing the same. It happens in scientific controversies. The believers in the traditional Ptolemaic Earth-centered solar system were baffled by the beliefs of Kepler and Galileo. The same was true in reverse. In fact, both sides of that famous dispute in the 1600s committed major logical and analytical errors that confirmed their beliefs. For example, Galileo managed to convince himself in the face of centuries of evidence that the moon in some way caused or influenced the tides. He managed to convince himself that the tides were a symptom of a kind of sloshing motion caused by the rotation of the Earth. This was a gross error. It looked totally ridiculous to other people, even in including Kepler, who was a colleague and also believed in the heliocentric theory, the new idea that he and Galileo were promoting. But Galileo made this amazing error in his otherwise frequently correct career. He wasn't thinking clearly. He had bought into the worldview that the Earth was moving, that it was spinning and rotating around, or spinning around the solar system, around the sun, which was the center of the solar system. He became so convinced of it, in fact, that he misinterpreted evidence that obviously showed, and had shown for centuries, that the tides followed the positions of the moon and the sun, which did not fit with tides being caused by the daily rotation of the planet. Where does our worldview come from? This is my theory. There's a lot of different theories of the worldview, a lot of variations in the definition of the worldview, but this is what I believe right now. A lot of our worldview comes from direct personal experience, and it seems very true, very certain. I cannot walk through a solid wall. I need food and water to survive. We don't believe these because we've read about it or because people have told us this, but from personal experiences, which are repeated and frequent in many cases. Bob was abducted by little gray men in a flying saucer. That's his experience, and we would have great difficulty believing it, even though he might have good reason to believe that it's true. So it's important to keep in mind that just because parts of our worldview are founded on solid experience, that doesn't mean we always have the same worldview or that it's always clear that that part of the worldview is trustworthy. Our worldview also comes from other people, from our family, from groups that we belong to and identify with, from our tribe or tribes. These can be things like our profession. If we're a scientist or an engineer or an attorney, often we identify with our profession and we get some of our worldview from what our profession or people in our profession seem to believe or say they believe. It can come from our country, what nation we belong to. This is a social reality. So what are some examples of this social reality, which can often seem absolutely as real as a solid wall we cannot walk through? I should not wear a pink tuxedo except as a gag. Washing your hands before performing a medical procedure is a crackpot idea, and this was believed by most formal doctors in the early 19th century, the 1800s. And on the right is a picture of Ignaz Semmelweis, who did scientific research, medical research, demonstrating that in fact it was quite dangerous and was killing many patients. He was in fact locked up in an insane asylum because of this belief, which is very well founded, as it turns out. We are susceptible to groupthink. This is the famous book Groupthink by Irving Janis, which gives some examples of instances where, according to the author, a group of people kind of locked on to an erroneous idea. And these examples are powerful, highly intelligent, highly educated people. It is not just something that happens to poorly educated, unintelligent people. Groupthink is a phenomenon that's been observed over and over again among high status individuals like medical doctors in the 19th century, and of course, ranking politicians and scientists like Galileo. We are just as certain of some key social realities as direct experience for some reason. We believe these things every much as certainly, with as much certainty as we believe we can't walk through a wall, or very close to that certainty. It's hard to explain why that is from a mainstream evolutionary theory. Since believing in a social reality can get you killed if it's wrong, and it is wrong, why do we believe these things? Because other people say. Now, of course, not everyone does. There are nonconformists, and probably all of us confronted with enough personal experience will break away from our social reality. In practice, it's extremely hard to change our worldview. It does happen. So how does this relate to data analysis? I've touched on Galileo and medical doctors in the 19th century. Modern computerized scientific and statistical methods do not solve this problem. Modern methods, which are more sophisticated than what Galileo has or had or the medical doctors in the 19th century had, these methods are usually computerized today, very computerized in fact, using very powerful computers and using sophisticated statistical methods automated with tools like numerical Python, MATLAB, Mathematica, the SAS system from the SAS Institute. These systems and these techniques are very complex and error prone. And if you study various controversies over, for example, the safety and effectiveness of drugs or medical treatments or vaccines, you'll see dueling analyses by highly qualified experts in many of these controversies. Oh, you forgot to do this. No, you don't use that test here. No, p-values are bad. Confidence levels are better. There are arguments on both sides. It is easy to produce a result consistent with your worldview, whether by deliberate deception or probably more often through subconscious bias, through so-called cognitive biases. Highly intelligent, educated people are excellent at finding special case explanations for even grossly contradictory data and logical arguments. And this happens frequently in these kinds of debates. It happened to Galileo. It happened in the 18th or 19th century with debates over the importance of sanitation, over washing your hands with antiseptic materials, or and so on. But it hasn't been fixed by computers, They, in fact, simply provide more sophisticated tools for sort of implementing our biases and our worldview, confirming it, proving that we were right all along. This is all very visible in the many disputes over the mathematical models involved in the current coronavirus COVID-19 pandemic, where you have heated debates over the interpretation of the data. I'm showing here, for example, John Ioannidis at Stanford University, who has argued that the infection fatality rate of the disease is probably significantly lower than the early estimates. And there's been a lot of heated and emotional dispute over this, and it is not yet really resolved. It may never be resolved, even if the evidence becomes incontrovertible. People simply don't accept evidence and data that contradicts their worldview. And the crisis has become intertwined quite clearly with the political viewpoints of many people. Certainly not everyone, and not necessarily John Ioannidis, for example. But as soon as you take certain positions, whether masks work or not, for example, what the infection fatality rate of the disease is, which seems like a rather dry number, in fact, you're going to find that there's a highly emotional response in many people, which derives from our worldview. How can we solve this? How can we get around this remarkably powerful effect of our worldview, where we can disregard, even in some cases, something right in front of our face? Even a direct personal experience that contradicts our worldview will often be rejected or rationalized away. And in fact, highly intelligent people, highly educated people, are really good at doing that. One possibility is to automate the currently custom parts of data analysis. This includes places where people tend to make errors. It also includes what are often value judgments. Should we use the mean, the average of a set of numbers, or the median, which is sort of the middle number in a sequence? So in other words, half the numbers are greater than the median, half are less than the median. An analysis can produce quite different results simply by choosing whether to use the average of numbers or a median. And there are many choices like this. Right now, they're usually made sort of by the analyst, and it's very easy to be biased in that decision, consciously or not, to let our worldview guide us. Well, we know this is the answer, so since the median gives us the right answer, we use the median. But if our worldview pointed in another direction, we would use the average. Will people accept the results of automated systems that contradict their worldview? Probably not. To some extent, we already see this. The automation must be an error. We see, for example, with the coronavirus model from Nell Ferguson or whatever, questions about the quality of the software implementation in that analysis. It's just a typical example. This occurs all the time now with many sophisticated data analyses in many fields, including, of course, important ones like medicine and health, but also in astronomy and physics and many fields. One sees heated debates over the accuracy of the software itself. Does it have a bug? It's very hard to prove, perhaps impossible to prove, but very hard to prove that automated software, in fact, is bug-free, is going to work and produce a reliable result. What else could we do to maybe solve this problem of data analysis, or rather the worldview problem in data analysis? What about some sort of cognitive bias training where we take people aside and teach them or lecture them about these cognitive biases? That hasn't proven that effective. Awareness of cognitive biases usually provides yet another means to explain away obviously contradictory data or analysis. Doesn't seem to work in practice. One can often see people in, let us say, public scientific debates like those over the coronavirus or climate change or other areas. You'll see both sides will invoke cognitive biases, the worldview of their opponents, conflicts of interest, various subconscious and sort of semi-conscious biases as an explanation for why their opponents are wrong. They understand these biases. They have somehow magically overcome them, but the other guys are biased. You hear this all the time. So in fact, our knowledge that these problems exist does not immunize us from us, does not protect us from these. A dramatic example of that is in the international bestseller, Thinking Fast and Slow by Daniel Kahneman. This helped to popularize some of these ideas about cognitive bias, although I don't feel he focuses as strongly on the role of the worldview as some research does. But here we go. One of the chapters in his book, in fact, was based on statistically underpowered studies with not enough data to support his conclusions, and he had the guts to admit that. Um, Now, keep in mind, this is a researcher whose main focus on these cognitive biases and problems and thinking carefully, and he did it. He did exactly what he knew about. This is a sort of individual example of something that's also shown up in some social psychology research, where highly intelligent people are often really good at rationalizing away contradictory data and getting the result they want, very often because of their worldview. So this leaves us uncertain. Probably automation of analysis, improving the automation of analysis beyond what we have with tools like numerical Python or MATLAB or the SAS program from SAS Institute. Probably more advanced automation can help to eliminate some issues. We don't have debates today over whether a program has calculated, usually we don't have a debate over whether it calculates the average or median correctly. That's all computerized. It's no longer done by pen and pencil by fallible humans, and that's not the issue. The issue, though, that remains is when is it appropriate to use an average as opposed to use a median? There are pluses and minuses to both numbers, and there are even alternatives that aren't as well known. Even if we can automate these kind of statistical judgment calls, which seem to be value judgments at the moment, if we can really pin down what you should do in a given situation, I don't think that's going to fully deal with the problem. Cognitive bias training has its own issues. It's probably not effective by itself either. So is there something else we can do to get around that problem? And that's one of the things that we're looking at here at Mathematical Software in trying to automate and improve mathematics analysis, data analysis in new and different ways to deal with these kind of problems. So we are developing automated programs that automatically determine what mathematics probably describes the data that we have, but it's not sufficient to do that. Even if we can do that, and we have examples of it, even if we can do that, we must be persuasive. We must be able to overcome the worldview problem, especially in highly sensitive areas, which is where these technologies can offer us the greatest benefits. If we can deal with global pandemics or heart attacks or cancer, it is very probable that these methods will produce results that people find contradict their worldview. They aren't the expected results. And in history, there's usually very bitter disputes over those results. It takes decades or even generations or centuries for what we now believe, and I say believe, to be the right result, like Galileo's results. Many of those have held up, and we now believe something very different from people at his time. But it took a long time for Galileo and Kepler's research and other of their contemporaries to be accepted. They weren't very persuasive. Galileo, in particular, managed to insult the Pope and wasn't very successful at promoting the results of his analysis. And indeed, he made serious cognitive errors in buying into his own worldview. So there's a real need not just to automate these things, to make a highly reliable system which doesn't have human error in it or has much less human error in it, but also we're faced with a long-standing problem that people's worldviews really bias. Bias is an understatement. It remains an unresolved question. How do we, both in ourselves when we do an analysis as well as when we're trying to persuade other people, can we get past their worldview? Can we get something to be accepted and believed if it contradicts the worldview that our audience has? And that is clearly an unresolved problem, but it's extremely, extremely important, and in some cases, life and death problem that needs a solution. This concludes this video presentation. If you like this video, please click like. Please click subscribe and the notification bell if you would like to receive more content from us. You can avoid internet censorship by subscribing directly to our RSS news feed. Please consider sharing the link by email or on your website or blog, in addition to liking, upvoting, or sharing on increasingly censored, advertising beholden, and big company social media. We have encountered such censorship. Mathematical software is developing software to automate data analysis, reducing the risks of costly errors and improving results. You can support our work financially by subscribing on our Patreon page. Scan the QR code in the lower right corner to get the Patreon link. Our Patreon link is also in the show notes below.